Hi everyone, this is lesson 4.3, normal approximation to binomial distribution. In this lesson, you're going to learn on how to use normal distribution table or to convert the binomial case or binomial variable to normal distribution variable. Let us begin. When we have type of random variable, we can have whether discrete random variable or continuous random variable. For discrete random variable, we actually have two types of distribution. One is binomial distribution, which is our lesson 3. And Poisson is not in our syllabus, so you can ignore this. You can ignore this. Oops, ignore this. And for the continuous random variable, we have learned on normal distribution, where we have learned on how to identify the value of probability from the table and find the value of z and so on. All right. So here in this lesson 4.3, we are actually going to transform the discrete random variable to continuous random variable, because we are transforming the random variable that is following the binomial distribution to random variable that's following normal distribution. And since we are converting from discrete to continuous random variable, that means you have to do continuity correction. Okay, because we are changing the nature of the random variable from discrete to continuous. And we are going to learn the normal approximation to binomial, and when to actually transform the binomial to this normal distribution is when n times p is greater or equals to 10, or the probability value is from 0.1 to 0.9. Okay, and this one, back to this, what is the continuity correction? Continuity correction means we have to adjust the value of x in the questions. So here is the table. You can find this table in your blackboard in the learning resources. I have pasted this table. So every time you want to do continuity correction, you have to refer to this table. So if the original question is probability when x equals to a, you have to adjust the question to become x in between a minus 0.5 and a plus 0.5. If we have x greater or equals to a as original questions, then you have to do the continuity correction where it will become x greater than a minus 0.5 and so on. Okay, so please refer to this table every time you want to do continuity correction or normal approximation. Let us look at the case scenario here. A magazine reported that 6% of Malaysians smoke while driving. So here, when we talk about smoke while driving, we have two possibilities only, whether smoke while driving or did not smoke while driving. So when there are only two possible outcomes, that means this one is binomial, right? Because binomial is the random variable, the distribution of random variable with two outcomes, right? If 300 smokers or 300 drivers are selected at random, find the probability that exactly 25 drivers smoke while driving. Okay. And all right, this is binomial. And let us take out the information here. 6% smoke while driving, and n equals to 300. Okay, and p is 0.06 smoke while driving. And we want to find probability of exactly 25 driver smoke. So to do this is binomial. You have to take out the n, p, and q. Just now I have done it. So n equals to 300. P equals to 0.06, 6%, right? And q equals to 0.94. Okay. before we go through all the other steps here, let us look at the questions. We want to find x equals to 25. You can actually use binomial to do this. Okay, if you don't actually refer to this, but okay, let's say I change the questions. Find probability that more than 25. So when I change the question to more than 25, it will be probability when x greater than 25. Greater than 25. Okay, how to find the value of probability for the binomial? You have to plus, right? When x equals to 26 plus x equals to 27. So this will be equals to x equals to 26, probability of x equals to 27 until probability when x equals to 300. So it will be a very long working steps if you still stick to binomial. Okay, this is why we have normal approximation when the n is large. Okay, when the n is large, you have to use normal approximation method to solve or to find the value of probability. Alright, you have to know why we actually learn, why we have to learn this normal approximation. This is the reason why. I think this is the clear example. Okay, more than 25 means 26 to 300. So it will be a very huge or a lot of probability that you have to find. Don't do that, but use normal approximation. Okay, it will be a lot lesser or shorter working steps. Alright, once you have decided, oh, you need to use normal approximation. So when you use normal approximation, what we do is you have to actually, okay, first you have to do continuity correction. So once you do continuity correction, you still have x, alright? For example, here is x equals to 25. In between, right? In between. So in between, okay, never mind, we will look at that in between. But once you have do continuity correction also, you will see it's still x here. Once we have convert to normal distribution, we actually want to find the value from the table. To find the value from the table, you have to change the x to become z. And to change the x to become z, from the previous lesson, z equals to x minus mu divided by standard deviation. Okay, so you have to know the value of mean and the value of standard deviation. And to find the mean and standard deviation, you will need the n, the p, and the q. Because for binomial, the mean will be equals to n times p, and the standard deviation will be equals to square root of n times p times q. Once you have converted the x to become z, then only you can refer to the table and find the value of probability. Okay, so step 3 and step 4 here is just to check whether normal approximation is needed. And for this one, n times p is greater than 10 or greater than 5. Some book use 10, some book use 5. So a normal approximation is needed. Or if you see the n is large enough like this, then you will know, oh, normal approximation is appropriate or needed. Okay, and okay, to find the mean, it will be n times p. We already find just now, which is 300, multiply with 0.06 equals to 18. And to find standard deviation, square root of npq, which is square root of 300 multiplied with 0.06 multiplied with 0.94. And this will give us 16 square root of 16.92, and it will be equals to 4.113. Okay, so once we know that, hold on first. Okay, just put aside first. Now we do continuity correction. So let me just paste this table here. Hold on, let me just snip this to that. Only need this one. And all right. So the continuity correction is when we have, just now the question asks us to find probability when x equals to 25. So this is binomial random variable, right? To use normal approximation, we have to do continuity correction. Referring to the table, it will be equals to probability when x is in between 24.5 and 25.5. How I get this value? I use this minus 0.5 and plus 0.5. So once you do continuity correction, that means you already transform the discrete random variable to continuous random variable. Once you do that, okay, now it's time for you to refer to the table of Z. And to refer to the table of Z, what you have to do is you have to transform first the X to become Z. And to transform the X to become Z, it will be X minus mean divided by standard deviation. Then here will be, you just write like this, 24.5 minus 18 is the mean just now. Okay, from here, mean is 18. Standard deviation is 4.113. So divide by 4.113. And from X, transform to Z. And then 25.5 minus 18 divide by 4.113. Then this will be 24.5 minus 18 divided by 4.113. Here the left side is 1.58 and then Z is 25.5 minus 18 divided by 4.113. 1.82. Alright? Okay. Here, once we have like this, then we can actually refer to the table. But before we refer to the table, okay, this will be equals to 1.58 here, and this is another 1.82. Before you refer to the table, you have to draw the bell-shaped curve to see where is the area and which one to minus which one. So here is 1.58. Both are on the right side of 0. And this is the area. Okay, so this one is equivalent to from 1.82 to the left, which is probability when Z less than 1.82, minus from 1.58 to the left, probability when Z less than 1.58. Why we have to do this adjustment? Because the table only gives us Z less than. So Z probability when Z less than 1.82, you look at the table, the row 1.8 and the column 0.02, the value is 0.9656. So it will be here 0.9656 minus, and we have Z less than 1.58. 1.58 refer to column 1, row 1.5 and column 0.08. And it will be 0.9429. 0.9429. And the final answer for this one is 0.9656 minus 0.9429. It will be here 0.0227. Okay, normal approximation. Another question here, let us try. According to the recent survey, 50.9% of households have personal computer. If a random sample of 300 households is selected, what is the probability that more than 175 households have personal computer? So here, when we look at this survey or this variable, whether the household have personal computer or do not have personal computer, there are two outcome only. So when there are two outcome only, that means this is binomial, discrete binomial. Let us take out the information here. The question first, what is the probability more than x is more than 175 have personal computer? So let the household have personal computer will be our x here. Okay, number of household have a personal computer. Probability or percentage of having personal computer is 50.9. That means our P is 0.509. Then this will automatically give our Q as 1 minus 0.509, which is 0.491. And the N here is 300. Okay, if you find N times P here, then you will see 300 multiplied with 0.509 is actually 152.7, which is exactly more than 10. So normal approximation is appropriate to solve these questions. Or if you see roughly here, we want to find x greater than 175. That means 176 to 300. So if you still stick to binomial, you have to find one by one from 176 until 300. It will be a very long working step. Do not do this. Okay? Use normal approximation. So step one, when you use normal approximation is you have to transform the discrete questions, discrete random variable to continuous random variable. How? You have to do continuity correction. So go back to the table of continuity correction. Now we have x greater than. So let me just paste it to the slide here so that we can refer. Okay, from the continuity correction, this is the correction needed. So it will be equals to x greater than 175.5. So once we do this, automatic from discrete become continuous. So once it becomes continuous and normally approximated, we want to use table of normal distribution. To use table of normal distribution, we have to transform the x to become z. To transform the x to become z, the formula is x minus mean divided by standard deviation. So we need to find the mean and standard deviation. Mean we already have 152.7. Standard deviation will be square root of NPQ, which is square root of 300 multiplied with 0.509 multiplied with 0.491. So here 300 multiplied with 0.509 multiplied with 0.491, and it will be square root of 74.9757, and we square root it, then we will get here 8.659. I make it to 3 decimal. Always make the value except for the z value to 3 decimal. Z have to be 2 decimal because in the table the z is always 2 decimal. So transform the x to become z, 0.5 minus mean 152.7 divided by standard deviation 8.659. So here 175.5 minus 152.7 divided by 8.659. Then we will have here probability when z greater than 2.659. 2.63. All right. Okay. Here, this one, if I draw the region, 2.63 is around here, and we want to find this shaded region. The table only gives us z less than, so it will be 1 minus probability when z less than 2.63. From the table, probability value when z less than 2.63, we have to refer to the row 2.6 and column 0.03. It is 0.9957. Is 0.9957. So 1 minus 0.9957, that's how we get 0.0043 as the answer. And this is normal approximation. Okay, first step is you have to do continuity correction. Once you do the continuity correction to the questions, then second step is convert or transform the x to become z. It will be s minus mean divided by standard deviation to find the mean, n times p. To find the standard deviation, square root of npq. And then from there, you have to find the z value from the table. If you need to adjust the question, for example like this, you have to use less than, right? You have to adjust first, then only refer to the standard normal distribution table. That is for the lesson 4.3. Thank you.